So everyone, in the last video we discussed about the Taylor's theorem, but now we will discuss the Taylor's theorem again, but this second type of question. Okay, so we know that Taylor's theorem was Taylor's theorem. We know what was the formula of Taylor's theorem. That was f of x plus h is equal to f of h and x plus x f dash s of h, then again plus x f double dash h upon 2 factorial plus x, sorry, there will be square, okay, then x cube f triple dash h upon 3 factorial plus and so on. Okay, so this was the formula. Now here I'm talking about second type of question. So how will be that question? Let me write down it in front of you. So the question will be something like this: expand 7 plus x plus 2 plus 3 x plus 2 cube plus x plus 2 to the power 4 in the ascending order of x. Okay, 1 minute, let me check. It is complete page recording or not. Yeah, so I think you will be able to see this. Yeah, okay. So now let's just begin. So before this we discussed a simple problem of Taylor's theorem, but this is something which we need to solve first, and then after we will be able to solve this. Okay, so here as we can see, x plus 2 x plus 2 x plus 2, this term is same in all question, so we can let that x plus 2 is equal to x. We let this just to make it easy while we write this, because if we will write again and again x plus 2, it will be so lengthy, so that's why I let this. Okay, so now I can write 7 plus x plus 3x cube plus x to the power 4. Okay, so now from here onwards we can easily apply the Taylor's theorem. We know the formulas to this, and we know we need this differentiation. So first of all, this is equal to f of x. So now here we will do f dash x. This will be equal to 1 plus 3 3 are 27, sorry 9 x square plus 4x cube and f double dash x is equal to 18x plus 12x square, and here is 4 times, so we need to differentiate 4 times. Okay, so f triple dash x is equal to 18 plus 24x, and now f 4 times x is equal to 24. It's quite simple. Okay, so now here we have the values of these. Okay, so now easily we can put it and get the answer. Okay. So let's put on the formula. So f of x plus 2. Why we did this? Because we will put here fx, then we have already let that x plus 2 is x. Okay, so we have right here x plus 2, or we can write x, no problem. Okay, so just now we are putting this in the formula. Okay. Okay, so before this, here we know this is x and this is h. So here we need to put the value of h so that we can get the final answer. So here if we will put f of 2, this will be equal to, okay, let me do complete because मैंने इससे पहले ये नहीं कैलकुलेशन नहीं की थी. Okay, so 7 plus 2 plus 3 into 2 3s are 8 plus 16. Okay, so 8 3s are 24, 24 plus 16, 24 plus 16 30 and 40. Okay, 40 42, or 42 plus 7 is 49. This will be 49. Okay, now f dash x, we will put 2, so 1 plus 2 is 4, 9 4 is 36 plus 2 3 is 8, 8 4 is 32. Okay, so 33 33 66 and 3 69, right? Okay, so this will be 69. Now f double dash x, we will put 2 in place of x, so 18 2 is 36 plus 2 is 4, 12 4 is 48. Okay, so this will be 8 6 is 14 and 4 3 is 1, 4 3 is 7 and 8 84. Okay, and next here 2 24 2s are 48, 48 plus 18 50 60 66 and divided is 24. Okay, so as you can see, I just did I have put the value 2 in place of x and nothing I did. Okay, why we put 2? Because here as we can see x plus 2 x plus 2, so we put the 2. Okay, now here we can easily put in place of this. Okay, so on formula f of 2, here this f of 2 and plus x dash f dash 2 and then plus x square f double dash 2 upon 2 factorial, or we can easily write 2, but okay, so plus x cube f triple dash upon 2, sorry, upon 3 factorial, and then fourth term x4 f4 dash 2 upon 4 factorial. Okay, then plus 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 plus. Now simply we will put the value f of 2, f dash 2, f double dash 2, f triple dash 2, f4 dash 2, because and we have find it here easily. 49 69 84 66 24. 1 second. 33. Okay. Okay. So fx plus 2 is equal to f of 2. Here f of 2 we have find out, that is 49. Okay, 49 plus x f dash 2. F dash 2 means this is 69. Okay, plus x square, and x square f double dash 2 is 84 upon 2 because of this 2 factorial, plus x cube f triple dash 2 is 66 plus x4, here also 3 factorial, we can easily write 3 into 2. Okay, x4 is this one, that is 24 upon 4 factorial, also the 4 into 3 into 2. We just did this. We know that if anything factorial, we can write it 4 into 3 into 2. We all know this. Okay, so now simply we have to solve this and nothing else we need to do. So simply if we will solve it, then there is f of x plus 2 is equal to 49 plus 69x plus 42x square plus 1 so 11x cube plus okay, so that was only x4. So what will be here finally, f of x plus 2 is x4 plus 11x cube plus 42x square plus 69x plus 49. So here I have write in the series wise. If anything is common, then we can take common, but here is nothing common term which we can take common. Okay, so now we will discuss Maclaurin's theorem. I'm not sure with the spelling of Maclaurin's. Okay, so this was just like Taylor's theorem, but here we need to do is, that is, here will be not any kind of value of h, so we will place 0 in place of h. Okay, so formula here will be like f of x plus h, f of h plus x f dash h plus x square of f double dash h upon 2 factorial plus x cube f triple dash of h upon 3 factorial plus x4 f4 times dash of h upon 4 factorial plus and so on. Okay, so this is the formula of Maclaurin's theorem, similar to the Taylor's theorem, but here will be that we will put h 0 because here will be not any value of h. Okay, so let's discuss a question. So we need to expand log of 1 plus e to the power x by Maclaurin's theorem up to x square. So yeah, here the question will say how many times we need to differentiate. Here is only x square, it means we will differentiate only 2 times. Okay, so here we have given f of x is equal to log of 1 plus e to the power x. Again, let me check, is this recording or not? Yeah, so it is recording. Let me focus it. Okay, so here we need to differentiate 2 times. So here f dash x is equal to 1 upon 1 plus e to the power x. Now e to the power x will be e to the power x. So this is one time differentiation, and again second time. Then this one here we will, here in the second time we will use u upon v rule, which is v square upon then v as it is, u will be differentiate minus we will differentiate u as it is. So we are using this formula. Okay, so 1 plus e to the power x as it is upon 1 plus e to the power x whole square. Okay, this is as it is, and this we will differentiate, then this will be again as it is minus e to the power x, this again this differentiation, that is e to the power x. Okay, yeah, so we will take here common e to the power x, e to the power x 1 plus e to the power x upon 1 plus, oh sorry, 1 minute, e to the power x, if we take common, then 1 plus e to the power x minus this e to the power x, sorry, minus e to the power x. So this term to this term will be cancelled. Okay, so here will be e to the power x upon 1 plus e to the power x only, square also. So this is f double dash x. Okay, f double dash x is equal to e to the power x upon 1 plus e to the power x whole square. Okay, oh yeah, so now we need to put x is equal to 0, so that we can easily put here and we can easily get the value of this. So x, we let this as h. So if we will put x is equal to 0, so here if we will put x is equal to 0, means f of 0 is equal to log of 1 plus e to the power 0, anything to the power 0 it will be 1, so this will be log of 2, and this f dash x will be 1 upon 1 plus 1 into 1, so this is 1 by 2, and this will be e to the power 0 upon 1 plus e to the power 0 square, means 1 plus 1 2 to the power 4, 1 upon 4. Okay, yeah, so now we will simply put in place of f dash f h, f dash h, f double dash h. Okay, so fh, fh is log 2 f of x plus 0, if we will put in place of this, then f of 0 plus x, f dash of 0 plus x square, f double dash of 0 upon 2 factorial. So we need to only write two terms because only x square in this question asked. So simply we will put the value f0 is log of 2 plus x dash f0 is 1 by 2 plus x square, f double dash 0 is 1 by 4 into 1 by 2 because of this 2 factorial. Okay, so now simply this will be our answer, log of 2 plus x by 2 plus x square upon 8. This was Maclaurin's theorem. Once again, let me just discuss in a previous question. We did some mistake. So which type of mistake we did here is, here we let x plus 2 as x. So here so many x are there. We will put x plus 2, then question will be complete. Okay, so f of x plus 2, x plus 2 to the power 4 plus 11x plus 2 to the power cube plus 42x plus 2 to the power square plus 69x plus 2 plus 49. So simply we have to solve this. How we will solve this? Simply x, we can do this x plus 2 square and into x plus 2 square. If something, how we can solve this, or if you studied in 11th class binomial theorem, by that also we can solve this. Okay, so now simply this is a plus b ka whole cube and this is a plus b ka whole square. Simply we will solve this and we will get the answer, get the final answer. Okay, now I'll discuss about Cauchy mean value theorem. We'll discuss about this. Okay, so concept is, here will be two terms, fx and gx. So first condition, as it was in Rolle's theorem and mean value theorem also, that it should be continuous, in given interval, that is a comma b or x comma y also. And second is, it should be differentiable in open interval a comma b. Okay, and one more thing, that g dash x cannot be equal to 0 because this will be in denominator. We know if 0 will be anything denominator, that value will be infinity, means not defined. Okay, so now for every a comma b, it lies everywhere. Okay, so now the formula is f dash c upon g dash c is equal to f of b minus f of a upon g of b minus g of a minus a to b. Okay, so this will be the formula. Okay, let me drink water, then after I will start. I hope camera will be able to focus it. Okay, so now take one question. So question is fx is equal to x cube and qx is equal to x to the power 4 closed interval 0, 2. So when we will solve it in paper, so first of all we will write that it is continuous. I am not writing here because we know that anything power, I mean polynomial power, is always continuous. Always continuous. Always continuous in closed interval 0, 2. Also same with, so differentiable open interval 0, 2. But in paper proper we will write, then after the teacher will think that to give marks. Okay, okay, so now here we have to find f dash x, g dash x, because question need that. So here fx is equal to x cube and f dash x is equal to 3x square. Okay, now here in place of x we will put c, then f dash c is equal to 3c square. Okay, and same goes with also qx. Sorry, this is not qx, it is gx. My phone battery is low, no worry. So gx is equal to x to the power 4, g dash x is equal to 4x cube, and g dash of c is equal to 4c cube. Okay, so now here we need to also find f of b and f of a, g of b and g of a. So here f of b means this 2, right? So here if we 2, then 2 to the power cube, then 8. Okay, and then f of a is equal to 0, we know. And what g of a also 0, and g of b 2 into 4 times 8, 16. Okay, so we have find all values. Now need to put in formula. So formula is to this, simply we will put here f dash c upon g dash c. F dash c is this 3c square upon g dash c is 4c cube, and f of b minus f of a. F of b 8 minus 0 upon g of b 16 minus 0. So this will be 1 by 2, and here this will be 3 by 4c is equal to 1 by 2. So here we can say 2 4s are 2 2s are 4. So c is equal to 3 by 2. Okay, so from here onwards c will be here and this will be 3 by 2. Okay, so now what should we discuss? Yeah, so there are some expansions which we need to remember in our mind. Expansion of functions. Like suppose e to the power, what is the expansion of e to the power x, and what is the expansion of sin x cos x. So we need to remember this. Sometimes we can directly use these expansions, that's why we need to discuss it. Okay, so first expansion is e to the power x, which is equal to 1 plus x square upon 2 factorial plus x cube upon 3 factorial, and so on. And second expansion is e to the power minus x, it is 1 minus x plus x square upon 2 factorial minus x cube upon 3 factorial, similarly x4 upon 4 factorial plus, sorry, here will be minus, here will be plus something. Okay, so now next come is sin x. What is the expansion of sin x is, okay, so it is 1 minus x cube upon 3 factorial plus x5 upon 5 factorial minus x7 upon 7 factorial plus x9 upon 9 factorial and minus something then plus. Okay, and now cos x expansion, simply opposite of it, I think 1 minus x square upon 2 factorial, and here will be, what will be here, I think x4 upon 4 factorial minus x6 upon 6 factorial plus, and so on. Okay, so now here comes log 1 plus x. What will be the expansion of this? Let me check, recording is going on now. Yeah, so it is going on. So here this expansion will be 1 minus x square upon 2 factorial plus x4 upon 4 factorial minus sorry it is simple x cube upon 3 factorial. Yeah, so it is confusing now. If we will remember all, then we will definitely get confused. So here let me write again. So 1 minus x square upon 2 plus x cube upon 3 minus x4 upon 4 plus x5 upon 5 minus x6 upon 6 plus so on. Now similarly log of 1 minus x, this is x minus, again there is one mistake, here will be x, okay, here will be x, so here x minus x square upon 2 factorial, so not factorial, minus x cube upon 3 minus x4 upon 4. Okay, so these are some expansions which we need to remember. So some are important, like we need to remember this one, this one, this one, and this one also, and this one also, almost all. Trick, we can say that what should be trick here, we can show this is odd, like 1 minus x cube upon 3 factorial plus x square 5 upon 5 factorial, and this is even. Okay, yeah, so simply we can learn it. Yeah, if we will use 1 or 2 times in the question, then it will be automatically remember. Okay, so now suppose there is one question that is expand 1 plus x to the power x up to x to the power 5. So how will you do this? Here we will simply use of expansion. So like how, we will let it like y is equal to 1 plus x to the power x. Okay, so we will take log y x of 1 plus x, 1 plus x, this is log, we have taken both side log, taking log. We also know one condition of log to the power n to the power n, and this n can come here, so this will be log y x log 1 plus x. Okay, so now simply we can use the expansion of log 1 plus x. So log y equal to x log 1 plus x. Let me check camera is focusing or not. Yeah, so it is focusing. So x log 1 plus x. What is the expansion of log 1 plus x? This is. So we will simply put it x minus x square upon 2 plus x cube upon 3 minus x4 upon 4 plus x5 upon 5 minus x6 upon 6 and so on. So this was the expansion of log 1 plus x. Okay, so this x will be go inside. So log y is equal to x square minus x cube upon 3 plus x4 upon 3 minus x5 upon 4 plus x6 upon 5 minus x7 upon 6. So if we will let it, suppose z, so log y will be equal to z. We can write if log will be that side and y is equal to e to the power z. Now we will again use the expansion of e to the power x. This is z, okay? So expansion of e to the power x is to this. So that is 1 plus z plus z square upon 2 factorial plus z cube upon 3 factorial plus so on. This is all equal to y. Okay. So now we can easily again differentiate it, then we will put the value of this and we will get the answer up to the x to the power 5. I am not doing complete because it is too lengthy, too boring. My motive was to understand that how we will use expansions in the question, so which I have I think discussed with you. So that is something how we will use expansions. Okay, so let's move on to the next topic, that is okay, so what we discussed right now, so we know some indeterminate forms. Indeterminate forms, some indeterminate forms. You know, these are 7 in numbers. Okay, so let me divide it in the series wise. Something like indeterminate forms. First part will be here, the second part may be here, third part can be here, fourth is this. Okay, okay, so 0 upon 0 form, this is indeterminate form, and infinity to the power 0. So this is LH rule. Okay, and next indeterminate forms are infinity, minus infinity, and 0 into infinity, and 1 to the power infinity, 0 to the power infinity, and infinity to the power 0, and 0 to the power infinity. So here we will take LCM to convert problem into So what we will do here is, here we will take LCM. To convert problem into, to convert problem into 0 by 0 form or infinity by infinity form by LHL rule or RHL. Okay, so what we will do here is, take any one of the term in denominator and convert the problem and convert it infinity upon infinity, 0 upon 0. So if we will find this, then we'll take log and convert problem to 0 into infinity form. Okay, so these are some indeterminate forms. Like also some like limits type of question, like evaluate limit x tends to 0 e to the power x minus b to the power x upon x. First of all, here we will put the value. If we can easily get the definite answer, then we do not need to do anything. So we and e to the power 0 minus b to the power 0 upon 0. So this is 0 by 0 form. So what we will do here is that we have write here is, if 0 by 0 form, then simply we can differentiate it. Okay, so here will be e to the power x log of a minus b to the power x log of b on 1. So here limit x tends to 0, we'll put here 0, 0, this will be 1, this will be also 1, then log of log a minus log b means log a upon b. Okay, so there is something how we will solve this. Okay, now just we will discuss some more concept. Okay, now I don't discuss the questions, because which topics I'm going to discuss, that question are so easy, we all can do this. So now some topics will be like comparison test and ratio test. Okay, so first comparison test. Let me check, is this going on recording or not? Yeah, so it is going on. Okay, so comparison test. Okay, so first point is, we need to find V and form. and un also. And one more thing, that is un is equal to summation of n upon n square, that is vn is equal to 1 upon n, right? Okay, so now second step is we need to check convergence of it. Okay, so how we will check convergence? Simply we will do that limit anything n to the power infinity un upon vn. Only we need to do this un upon vn, and we will find the if this is convergence or not convergence. Step 3, sometimes we also use to find answer of question with the help of p series. So what is this p series? Is n is equal to 1 to infinity 1 upon n to the power p is equal to 1 upon 1 to the power p plus 1 upon 2 to the power p plus 1 upon 3 to the power p plus 1 upon n to the power p. So this is p series. One more thing, need to remember is if p will be greater than 1 in vn, then it is convergent, and p will be less than 1 or equal to 1 in vn, then it is divergent. Okay, so this was p series. Now let's move on to the ratio test. So simply it is similar to the comparison test. Like we need to find the first un and then un plus 1. Simply we will find un, then only we will add n plus 1, and then we will put, and simply we write like un plus 1 upon un. Simply here, from here onwards, we will get if this is convergent or not. And this will be equal to L, and need to remember that if L will be less than 1, it will be convergent. L will be greater than 1, this will be divergent. Okay, simply we can do this. Now what is remaining? Okay, so one more thing that I should discuss, that is Cauchy root test. So what is this Cauchy root test? One more thing, that is this is only used for n square or n to the power cube. Just we need to find here first un, then un to the power 1 by n, and need to write something like this: limit n tends to infinity un to the power 1 by n is equal to L. So here if condition say kuch, if L will be less than 1, this will be convergent. L will be greater than 1, this will be divergent. L is equal to 1, then it's fail. Okay, so almost I think which I should discuss for single variable unit. I have discussed. Now we will discuss second unit, that is sequence and series. Thanks for watching.